This lesson covers some material out of Unit 3-4 using algebra. We're going to take a look at content out of box E, multiplying and dividing monomials by monomials. And the first thing we want to do is we want to refresh our memory on what a monomial is. So if you recall from our work in the previous lesson, I've written 1, 2, 3, 4 things here. These things are all monomials. And that's not how you spell monomials. It's got an N in there, monomials. And how do we know that these are monomials? Well, we know that mono means one, so that these things have just a single term. Okay? Now, in this single term, we have a couple of parts. If we look at 6x squared here, we've got the 6, we've got that x. What special name do we give that 6? It is called the coefficient. And what do we call the x? We call that the variable. Good. So we've got a coefficient and we've got a variable. If we want to multiply two monomials together, we've already talked about this in Unit 1-2, so this should be a little bit of a review for you. But what we want to do is we want to multiply the coefficients together, so multiply those numbers out in front, and we're going to use the exponent rules that we used in Unit 1-2 to the variables. Namely, if they have the same base, we can add the exponents. So let's take a look at the first example here. We've got 4x squared times negative 5x cubed. And what the learning guide gets you to do is when you see something like this, is to rearrange it a little bit. We're multiplying everything together. We're multiplying 4 by x squared by negative 5 by x cubed. So they get you to kind of rewrite it so the numbers are out in front. 4 times negative 5. And then the variable parts are next to each other. X squared times x cubed. And then just multiply. 4 times negative 5. Negative 20, and then x squared times x cubed. Well, we're going to keep our base the same, and because the base is the same, we can add our exponents, 2 plus 3. And so for our final answer, we're actually going to add those exponents together to get 5. And I can put a little box around our final answer here. Okay. So for our next one here, we've got 4ab squared times negative 3a to the 7th. Okay. First, we're going to multiply our coefficients together. What do we get when we multiply those two coefficients? What do we get here, Nicole? Yeah, we got a negative 4 and a negative 3, so we multiply those, we get a positive 12. And then we look for variables that match up here. So I got an a here, I got an a here. I want to multiply those two together. So that's an a and a to the 7th. And then I've still got that b squared kicking around. So I'll just keep that 12 there. Now, how do I multiply a and a to the power of 7? What do I have to remember? Yeah, I remember that if I don't see an exponent there, that there's a 1. And so I add those two exponents up, a to the power of 8. And what do I do with this b squared? I don't have anything else that has the same base as b, so I'm just going to keep that b as b squared. And I'll just put a box around my final answer here. Okay, last one here. For multiplying, we've got... what do we have here? We got a squared x cubed z times negative 2x cubed y squared z squared. Okay. What are our coefficients here? Lexi? And we don't see anything else. We just see a negative 2 as one of our coefficients. So what do we do in this case, Lexi? What do you think? Yeah. We assume that there's kind of a 1 out here, and so we multiply the 1 and the negative 2 together to get negative 2 as our coefficient. And then we're going to look for things that match up here. We got an a squared. Is there anything that we can multiply with that a squared? People are shaking their heads. No, so it's just going to say a squared. What about this x cubed here? Is there anything that has the same base as that x cubed, Stefan? Yeah, so we add those exponents there. We get x to the power of 6. We've got a z here and a z here, so we're going to multiply those together. What's our exponent going to be on z after we do that multiplication here? Emily? Is it 4? So what do we have on the 1z? We got a 2 here. What do we have over here? We got a 1. So we add them up and we get 3, right. And finally, we don't have anything that matches up with our y squared. So this is just y squared. Okay. Oh, and I need to put my box around it. Okay. So when we're multiplying, we multiply our coefficients, apply the exponent rules. Base is the same, we add the exponents. Similar thing for dividing. Okay, we want to divide our coefficients, and again, apply the exponent rules to our variables. We match up ones that have the same base, and then we subtract the exponents. So what's easy if we have something like negative 20x cubed divided by negative 5x squared? Often it's easy to rewrite it as a fraction, as negative 20x cubed over negative 5x squared. And as we do this, we sort of line up the things that go together. We're lining up our coefficient, and our x variable, and our other x variable. And then we can do our division here. So negative 20 divided by negative 5. Let's see, I've got a negative divided by a negative, so that's going to give me a positive. 20 divided by 5 gives me a 4. X and x, so the base is the same, and I'm going to subtract my exponents. 3 minus 2 is going to give me 4 to the x. 4x. And my exponent would just be 1. But if the exponent is 1, I just don't write anything there. Okay. Let's take a look at our next one here. Move this up a little bit here. So I've got negative 4, a to the power of 10, b squared, divided by negative 12, a to the power of 7. I'm going to rewrite this with my negative 4, a10, b squared on the top. And then down in the denominator, my negative 12, a to the 7. And when I do that, I see that nothing matches up with that b squared. Oh, now I can do my division. Negative 4 divided by negative 12. Now that's not going to divide evenly. Okay, so I'm just going to say, well, I got a negative divided by a negative. That's going to give me a positive. And I'm just going to write this as a fraction. 4 over 12 right now. I've got a to the power of 10 divided by a to the power of 7. What's going to be my new exponent on a here if I do that subtraction? 3. And what do I do with this b squared? Well, this is b squared and nothing down here, so this just stays as b squared. Now, what can I do with this 4 over 12 here? I've got a fraction. Do I just leave it as 4 over 12? No, I do something to it first. I want to always express these fractions in lowest terms. So I think about, what can I divide into 4? What can I divide into 12 evenly? Liam? 1/3 is going to be my fraction. I can divide each of these by 4. Okay. We got this last one over here, which is already written nicely for us. We've got a 4a cubed b8 c divided by a squared b5. Let's see. 4, I don't see anything down there, so I assume that there's a 1. 4 divided by 1 just gives me a 4. What's my variable portion going to be here? You can probably see this one on your own here. Nezrat, have you got this one? And why is it just a?
Because when you subtract 2 and 3,
3 minus 2 gives us 1, so we just leave it as a. And then what about for our b here? B to the power of 3, because it's 8 minus 5 gives us 3. And then finally, we don't have anything to match up with this c, so the c is just left sitting around. Okay, and put a box on it, and we are done. This is